Hey there. So for my Module 8 reading, the article was titled Building Mathematics Curricula with Applications and Modeling. It was written in 1989. It's from that perspective. So just as an introduction, Usiskin discussed the complexities of the mathematics curriculum. Um, He gave examples of how much of it is crowded, which makes it difficult for students to complete all the topics because it's like things are constantly being added, but nothing's really being taken away. So things become the discretion of teachers. And he gave an analogy of like going into a skyscraper if you're giving like a tour or something, and how if it's a large enough building, like you could have a completely different experience depending on who your tour guide is. Um, so despite the absence at the time of a national curriculum, most high school students followed some very similar content through textbooks. But as I said before, that curriculum crowding kind of made different emphasis on different subjects, and that um, pertain to applied mathematics. So, with the goals of mathematical modeling, Usiskin referenced NIS from a conference, um, and he or she outlined the modeling goals. And the point in modeling was to foster creative problem solving competencies, to help generate critical thinking and um, context and scenarios of problems, to develop practical skills for real world usage, and balance the perception of mathematics and enhance conceptual understanding. So, those are the purposes of developing modeling within a mathematics curriculum. Um, and he also emphasized the need for a structured applied mathematics. So traditionally, applications were used for the ends of the spectrum. At the time that this article was written, students within the middle didn't get a whole lot of applied mathematics. Applied mathematics were used for helping those struggling students and try to understand concepts that they weren't grasping with, or on the opposite end of the spectrum with higher achieving students, it was viewed as going in deeper, like with projects. Um, so Usiskin argued that the usage of applications within mathematics needs to be to engage all students, to better develop their understanding. And the variety of applications of mathematics requires a structured approach because there's so many within, and that's why he argued that applied mathematics needs to be viewed as its own discipline. He then talked about challenges with applied mathematics curriculums, and he kind of talked about ways that um, it could be organized because that was one of the challenges there. So it needs proper. He argued that it needed proper sequencing, and his suggestions were hierarchies with prerequisite knowledge before you move. You got to go do this thing before you move to this thing, from one step to the next. He also explained that theoretical reasoning, real world applications, and representations need to be a part of an applied mathematics curriculum. Proofs and modeling need to be integrated throughout the process, and processing from exact representations to pushing students to be more flexible than their representation would also be needed in developing an applied mathematics curriculum. Toward the end of the article, he talked about technology integration in mathematics as well, in the context of applied mathematics. And what another one of those challenges in developing that curriculum is determining what needs to continue to be done by hand versus what can and should be done with technology. And another challenge with the use of technology is ensuring equitable access to technological tools. And at the time, calculators had been um, uh, becoming more advanced as well as computers. But there's no point in creating this applied mathematics curriculum if calculators, if it's used in alongside calculators and computers if only a small portion of the population have access to them, then there's really isn't no point in developing the curriculum in that way. So making sure that technology was accessible to all students was something that he argued for, and I still see that today. He also talked about how there's oftentimes pushback with the integration of technology, um, and how it really does relate to our applied mathematics today. So in the past, he gave the example of in the 15th century, the applied mathematics of that time would have been basic arithmetic, and that was what was needed. If you go back to the earlier part of the 19th century, I would even argue that was what was necessary at that time. But as calculators developed, the applied mathematics was really no longer basic arithmetic, and it kind of evolves and it advances, and that was what he discussed, and how um, applied mathematics is something that has to be reconsidered and revised as computers continue to advance and shape um, applied mathematics. And we got to encourage our mathematics teachers to change as well and not hold on to traditions as we develop the curriculum. Um, so to close, just to wrap up the thoughts of the article, Usiskin emphasized the importance of structured and applied mathematics. Modeling and applications enhance the engagement in mathematics and give the real world relevance that students need to learn math at a deeper level. And technology and curriculum adaptation is going to continue shaping mathematics education.